I know, I said don't care. Didn't tell me.
No, I was
What was that? Alright, we got y plus 2 over y over y minus 2 over 3y. You'll be quiet. This is why it's called complex fractions. We got fractions within fractions. It's like fractions on overload. We got them everywhere on this. Well, our goal is going to be to make this problem into what we did last week when we did Ninja Math. That's going to be our goal. This one is ready to go with that. Because what I'm looking at and what we're going to see throughout the class period is that this one has only one denominator on top. Pay attention. And only one denominator on bottom. When it starts having more than one piece on top and bottom, that's when we've got more fun and more work to do. But right now, this is okay. This is ready to go. This big division bar here tells me I'm taking this fraction divided by this fraction. And I know I can do that by multiplying the reciprocal. Okay, so this is going to be y plus 2 over y, just kept that one the same, times reciprocal 3y over y minus 2. Now that was no big deal at all, because now we've done this problem before. We should see that there's only one small thing that we can ninja. What is it?
Y plus 2.
No, can't do the y because one of them's a y plus and one of them's a y minus. Good, Mason. Y and y.
Yeah.
So all I've got left on top is 3 times y plus 2, and on bottom, y minus 2. I'm done. If you want to distribute the 3, you can. I don't unless I can't find a choice and I need to go farther. Some of these problems are going to take a while, so I don't do extra work on them unless I have to. Okay? That one's pretty basic, pretty straightforward. It was ready to go. Okay, let's look at one that wasn't ready to go. Good idea. Thanks. I'm glad you asked. Everybody got it? Okay.
Now I got it.
Now we're Now we see. 2 plus 1 over y over 3 minus 2 over y. Alright, this is where we're actually going to connect last week's stuff to yesterday's stuff. Okay? What we've got on the top, this has a denominator of 1. Caleb, this has a denominator of y. They're not the same. On the bottom, I've got a denominator of 1 and a denominator of y. So on each piece, top and bottom, I've got plus stuff or minus stuff. I've got more than one denominator. So we first off have to do like we did yesterday and get a common denominator. So on the top, looking only here, what would my common denominator be?
Y.
Very good, Mason. So we're going to start it off like we did yesterday. On this side, I had to multiply the bottom by y, which means I have to multiply the top by y also. The 1 over here, I didn't change anything, so I don't change the 1. So that means I have 2y plus 1 over y. Now my top piece only has one denominator. Okay? We've got to do that same process now for the bottom piece. What will the denominator here be? Good, good, Caleb. It's y again. What about the 3? What do I need to multiply the 3 by?
Y.
Good, Kaylee. It was a 1 on the bottom. I multiply it by y, so I multiply the top by y. What about the 2? What do I multiply it by? Right? Because I didn't change it. It already had a y, so I don't change that 2. 2 times 1 stays 2. Good, Mason. So now I can write that as 3y minus 2 all over y. So all of that work just now got us to where the last problem started. We just now have one denominator on both bottoms, right? So we're going to multiply the reciprocal now that we finally got there. So I'm going to keep the top one like it is. 2y plus 1 over y times reciprocal of this one. Now, I still had somebody in first period that wanted to multiply straight across the top and straight across the bottom, and you can. If you do that, then you would later have to factor and reduce. What we do when we use Ninja Math is we're just reducing first. So that's the method I choose, because reducing first keeps me smaller numbers. But if you want to multiply across the top and across the bottom, you can. And then you'll just factor and reduce. But right now, I can go ahead and reduce by taking those y's out. Then on the numerator, I've just got a 2y plus 1. On the denominator, a 3y minus 2. That's it. What? I got what we need on that one?
Yeah.
Yeah. Alright, I got 2 over x minus 3 over 5 over x squared minus 9. Do I need to get a common denominator on either part, top or bottom?
I think they listed a pie.
Do I need to get a common denominator on either part? Very good, Mason's correct, I do not.
Teachers, please excuse the interruption. We need the following students to the junior high lobby for who's who pictures. Skylar Wise, Sam Neal, Dawn
It was a trick.
Alright, so no was right, Mason said, because this is all one denominator. There's no plus or minus out here to the side of it with something else. This is all one denominator. There's no plus or minus out here with something else. So we're ready just to go by multiplying our reciprocal. So 2 over x minus 3 times. Here's where you've got to realize something. When you take the reciprocal of 5 over x squared minus 9, x squared minus 9 can be broken down, and you need to do that. What's x squared minus 9 the same as?
X plus 3x minus 2.
Bailey's got it. Right? Everybody remember that? We've been factoring forever now. X plus 3x minus 3. And then there's your 5. If you had missed that, you would have probably missed you've got something that you can ninja, and then you would have had to have done it in the end. It would have been a little bit more difficult. Now you see you've got x minus 3, x minus 3. So on your numerator, 2 times x plus 3, and on your denominator, 5. I get old. What? No. Why? Alright, this one we've got 5 over y plus 2 all over negative 3 over y squared minus 4. I want you to try that one on your own. Go. 5 over y plus 2 all over negative 3 over y squared minus 4. Exactly like the one we just did.
I was thinking water pictures. I don't know if they called me.
No, we didn't.
The answer is 12.
I know, I was joking. Why do you keep doing that?
What boy?
Are you trying to mess with me? Why? I have part of my conference from home.
Negative 226.
Times 10 plus 4. Minus 9.
Well, let's see. You can
You know, put 2 on.
I'm in.
I don't look at him. No.
Okay, all I did was took the reciprocal of the bottom and I factored the piece that could be factored. Okay, what I need to finish, I'm not done. Is there anything I can ninja?
Yep, the y plus 2.
Kid, shh, shh. So on the top, I got 5 times y minus 2. And on the bottom, just a negative 3, which is what Caitlin had. Good deal.
Stop. I love her. I'm really good. No. No. You don't have to chill out with that crap. No. No.
Alright, I got m to the negative 1 plus p to the negative 2 over 2m to the negative 2 minus p to the negative 1. Alright, so obviously the new part here is we're looking at negative exponents. No secret in that. Can't hide that. What does a negative exponent tell us to do?
You just flip it.
Very good. Very good, Mason. Take the reciprocal and make it positive. So my reciprocal of m would be 1 over m. And m to the first is just says m. So that first piece would be 1 over m. Plus reciprocal of p is 1 over p. And then I make that squared a positive. Okay? Now, looking at that, just the numerator, we're not going down to the denominator yet. Now I need to get a common denominator out of that. If I have an m and a p squared, what would my denominator be? No?
MP
Very
squared.
good. You would take the product, mp squared. Okay? Only had an m here. I multiply by p squared, which means I need to multiply the top by p squared. Only had a p squared here, multiplied by m, so I need to multiply the top by m. So now I can write that over one denominator, p squared plus m over mp squared. Okay, I'm just going to kind of put that in a little rectangle there. That's my new numerator. I'll have to mess with that in a little bit. Now we've got to repeat the process for the denominator. Be careful on that though, because you got to realize, you got to figure out about this negative 2. Is it to this whole product, or is it just on the m? Very good, Mason. It's only on the m. If it were to the whole product, Caitlin, you're going to have to move if they can't quit talking to you. If it was to the whole product, it would be only on the 2. Yeah, sorry, they confused me. If it were to the whole product, it would be in parentheses. That's what I meant to say, and that's what Mason was talking about. So it's only on the m. So when I go to take the reciprocal, that 2 stays on top. It's just the m that will go on the bottom. So I'm going to have 2, because the power wasn't on the 2, right? Over m squared minus 1 over p to the first. Now, what would the common denominator there be? No.
M squared P.
Good. Mason, just multiply those. M squared P. M squared P. Almost the same as the first one, but not exactly. M squared P. This one I multiply by P, so multiply that 2 by P. This one I multiply by M squared, so multiply that 1 by M squared. That gets me 2P minus M squared over M squared P. So there's my new denominator. So I'm looking over here on the far right in my dotted rectangles at this divided by this, which now finally, a smartboard page later, I'm ready to multiply the reciprocal. I had to do all that to get it ready to multiply the reciprocal. So pick up a new color so we can see it a little bit. I got p squared plus m, my new numerator. I'm writing this one over m p squared times, I'm going to take the reciprocal of this one, so m squared p over 2p minus m squared. Took the reciprocal of that one. Alright, there is things that you can ninja, but be careful about it. The binomials cannot. Remember, you've heard me say a million times in here in Algebra 2, you can't pick apart a binomial. So the binomials, which would be this one and this one, they're not the same, so I can't mark them out, I can't pick them out. That leaves these. Okay, so I've got an m squared over an m. That cancels the m out and drops the m squared to an m to the first, right? Is that okay? Alright, on my p's, I got a p over a p squared. So this time the smaller one's on top. So that p would cancel, and this would go to p to the first. So on the numerator there, I've got this m times p squared plus m. On the denominator, I've got that p times 2p minus m squared. Thought. Remember I told you some of these are going to take a while. You don't want any extra work. So that would be a time when I sure wouldn't want to be distributing that M and P unless I had to. If I don't have to, I'm good. That's correct. I'm going to stop. Alright, I'm going to go back and give you another easy one and work your way up. Yeah, that's the hardest out of those that you'll see. Alright, this one I've got says k plus 1 over 2k all over 3k minus 1 over 4k. Okay, this is back to like the very first kind that we did, one of the simplest ones. I want you to try it. Go. You're going to lose your brains trying to shake that pencil out. Gotta get it. Let's go. Okay, that one already ready, just to multiply the reciprocal. Right? Everybody okay on that? So I've got mine set up. Is there anything that I can go ahead and reduce? It's the correct way to say that. Ninja math is just something I've made up. Is there anything I can do? What?
Okay.
Very good. 4K over 2K is just 2. Right? So my numerator, I have 2 times K plus 1. It's okay if you want to distribute that, but you don't have to unless it's not a choice. And then on the denominator, I've just got 3K minus 1. How'd you do?
I do pretty good.
Thumbs up,
I
Calvin.
accidentally flipped the second one.
Well, you do
The
flip
first
this.
time.
Oh.
Like I left it as 4K on the bottom.
Oh,
By accident.
I got you.
Put it.
I got you, sir. One more. Alright, this one is not ready to multiply the reciprocal. Neither piece is ready because neither one of them has one denominator. On this top, I've got a b squared and a squared. That's 2 separate denominators. I need a common one.
I'm looking to high school office.
On this bottom, I've got a b and an a. That's 2 separate denominators. I need one. So your first job is going to be to get a common denominator on both top and bottom like you did yesterday. I'm going to let you swim and tread water for a little bit, then I'll step in and then we'll go from there. I want you to try it, see what you can do.
Bien, está open. Your common denominator on the top piece is going to be b squared minus a squared. You alright on that? So this one already had a b squared, so when I multiply it by a squared, it'll be that. This one already had an a squared, multiply it by b squared. So that means this piece would be a squared minus b squared. This one already had a b, so multiply it by a. This one already had an a, so multiply it by b. It would be a minus b. Now it's ready to multiply the reciprocal. Go, if you weren't already past me. What did I do that caused y'all to erase? Yep, that a squared minus b squared can factor, can it? So right here, okay, it was up there at the top. Let me scroll that for you. This a squared minus b squared is the same as a plus ba minus b. Not completely necessary for you to do that, but way easier when you do. Because now you see you can do this. Right? Is there anything else you can mark out?
BA.
Very good. Can take these out, and that would drop these both to a first power, wouldn't it? So on the top, all I got is a plus b. On the bottom, all I've got is a times b. Not too shabby. Not too shabby.
Why was algebra invented?
To solve for unknowns.
Why are unknown things?
Because you don't know everything.
I just,
There's always some unknown.
Not
Alright, tomorrow you're going to have an assignment. Okay, assignment will be in your classroom tomorrow. Everybody good? Alright.
how long do you think that lasts from the second skill?
Usually lasts sort of lunchtime.
What is it?
As
Oh, y'all got
juniors.
that app there?
Yeah, all the juniors have that as vaginal. Zane, you can go